Here there are 4 capacitors, identical, each with 15 microfarad, connected as per the diagram to a 500 volt supply. First part of the question, find the equivalent capacitance. Second part, charge, potential, and energy stored in each capacitor separately. So by seeing the arrangement, it's clear. C1, C2, C3 are in series. We try to draw a line, a path without any branching, only a single path. All those capacitors in the single path are in series. We start from here, there's a double junction, branching. That is not series, but after the junction from just before C1, only a single path till here. At this point again, there's a branching. So till here, C1 till C3, they are in series. So all are identical. For identical capacitors in series, the total capacitance will be value of one capacitor by number of capacitors. So value of one capacitor is 15 microfarad. By there are 3 capacitors. By 3, 5 microfarad. Now if you replace these 3 by single capacitor, that will become parallel to C4. So these 2 are in parallel. In parallel combination, the effective capacitance will be sum of the capacitors. How we decide parallel? Like series, it's a path without any branching. Where the branching starts, till that only series. For parallel, all one side plates, left side plates P1 are connected to one single point. All the other plates are connected to another single point without anything in between. There should not be a resistor, there should not be a cell. Just capacitors 2, 3, 4, whatever be the numbers, all with one plate together to one point, the other plates all together to other point is called parallel. Now you add these two, you get the total capacitance. It's already 5 plus 15. That will give you 20 microfarad. That's the effective capacitance. The first part is done. Now for the charge on each capacitor, we check C4. C4, C1, 2, 3, both are parallel to the cell. That means this voltage is same for C4 and C1, 2, 3. So voltage across C4, V4. Voltage across C1, 2, 3, which is V1, 2, 3. V1, 2, 3 and V4 are same. That's equal to 500 volt. Since we got V4, you can find Q4. Q4 is just C4 into V4. C4 is 15 microfarad. V4 is 500. So 15 into 10 to minus 6 into 500. 2 zeros will go 10 to minus 4. 5 into 15, 75. 75 into 10 to minus 4 or 7.5 into 10 to minus 3 cube. Now you got V4, Q4. You can finish the energy stored in that capacitor. Energy stored in a capacitor is, there are 3 formulas. Half CV square, QV by 2, Q square by 2C. Any one we can use. I'm using half C4 V4 square. C4 is again 15 microfarad. V4 is 500, so 500 square. Half into 15 into 10 to minus 6, 500, 500. Calculate it, come to be 1.875 joule. Make the two zeros cancel with 10 to minus 6, so 10 to minus 2. So 5 into 15, 75. Again 5. Then divide by 2, 1.875 joules. So that is done with charge, potential, and energy of C4. Now, if we check C1, C2, C3, they are in series. So the total voltage will be V1 plus V2 plus V3. V is equal to V1 plus V2 plus V3. Since all of them are identical, the voltage also will be equally divided. V1 equal to V2 equal to V3. So if we substitute that here, V1, 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 all the three are V1. So 3V1 is equal to V, which is 500. So V1 will be 500 by 3. That will be same for all the other. So the total voltage is equally divided across three identical capacitors. It's only possible because C1, C2, C3 are identical. Now C1 is identical to C2 and C3. V1 is identical to V2 and V3. Automatically charge also will be identical. So Q1 equal to Q2 equal to Q3, which is either C1 V1 or C2 V2 or C3 V3. C1 is 15 into 10 to the minus 6. V1 is 500 by 3. So to multiply again 10 to the minus 4. 75 by 3 is 25. So 2.5 into 10 to the minus 3. So all the three capacitors together solve with voltage and charge. Now energy. Energy is half CV square again. Since C and V are same, all the three charges, potential and energy also will be same. So anyone you can calculate C1 V1 square with half. So C1 is again 15 to 10 to the minus 6. V1 is 500 by 3 into 500 by 3. That you can calculate the value coming as 0.2082 approximately.